In this video, I'm going to show you how to use the rotary attachment on your CNC machine to make these candle holders. So before we get started, I want to make it really clear that this project is for new to rotary or people that are interested in rotary. If you're looking for advanced techniques, this probably isn't the video for you, and there's all kinds of other videos out there on that. So bear with me. This is going to be some really basic stuff, but it's going to be perfect for you guys out there that are really just getting started, okay? So what we're going to do in this project is we're going to start off by going over how rotary works on most machines, then point out some differences with our machine here. Then we're going to jump into the software and do some test cuts so you can see exactly how your rotary is going to react when you put it into use. So this is what we're going to use for stock, and we're going to measure this up later and we're going to put it in our machine. So let's go have a look at our machine and see how it relates to the job that we're going to create. So right now, as you can see, we have our rotary is off to the left of our machine. Now in this machine, the Y runs across the front and the X runs up and down. Okay, so it's important, our orientation of our rotary on this machine is on the X axis. So let's pretend that this piece of paper is our actual material. So in our software, we're going to treat it as a flat thing, and then we're going to wrap it around. So we have our X axis is here, which goes this way, and then we have our Y axis, which goes across this way. So essentially what we're going to do is this dimension here across the front of our paper is going to be our circumference of our material. And if we wrap that around, then we're going to end up with a job that looks a lot like this. So we're going to take our Y-axis and we're going to wrap it around our material. Now what this is going to mean is that we're going to have to do some special setting up of our machine. So I can easily find the X-axis. I can just line it up with maybe the center of my tailstock. Or in my case, what I'm going to do is use a router bit mounted into the actual chuck of the machine, so I can line up a V bit with the center of this, and that will give me the direct center in X and Y of my rotary here, which is going to be really important to have. And in the software, I have the choice to either zero the Z-axis off the center of my material or off the surface. In our case, because this is set up a little bit awkwardly, we're going to be setting our zero off the surface. Also, it's kind of hard to do a tool change with our setup that we have right now. So yours might be a little bit different. So think that through a little bit when you hit your project. So what we're going to do is when we get around to actually cutting this, I'm going to set my X and my Y to the center point of this. Then I'm going to pull it out of the way. We're going to put our tailstock, or put our piece of material in, excuse me, tighten up our tailstock, make sure it's nice and level, and then we can go ahead and zero the Z off the top of our material. And that's pretty much it for the setup. It's not as complicated as it may look when you first think about using your rotary. So now what we're going to do, we're going to take all of that and we're going to jump right into the software and we're going to create some really basic test cuts so we can make sure that everything works out. Now keep in mind, this project is going to be trial friendly, so you can go ahead and use this even before you own our software and make sure that your rotary works properly with what we have to offer you. Great, so let's just go ahead and open up Vcarve Desktop and get things started. So here we have a new instance of Vcarve Desktop up and running. And like I mentioned before, we're not going to get into anything advanced here. And also, I wanted you to be able to use this in your desktop software, so we won't be using any gadgets. One of the gadgets that we have is called a rounding gadget. So if you have a square piece of stock, you can use it to knock the corners off of that square piece. But in our case, we're going to have an already rounded piece already to start with. So I don't need to worry about using that gadget. A couple things to think about when you're looking at this material is that this is not perfectly round. It looks like it is, and when I ordered it, it should have been 60 millimeters round, but it's not perfect, but we're going to go with our best guess. That way we're going to get, we can hope for a decent result. If I wanted to, I could run a pocket toolpath around this just to smooth it out and get it all the right thickness, but for right now, we're just going to leave it as it is. Okay, so let's go ahead and start a brand new file. And again, in this case, we're going to make sure that we choose a rotary job. Now I'm going to go ahead and measure the length of this, but we need to keep a couple things in mind. So if I go ahead and measure this up, I think it's around 500 millimeters long. Part of this is going to be stuck in the chuck, or the jaws of my chuck, so it's going to be inaccessible, along with some of it I'm not going to be able to get to because of the diameter of my collets and so on. I don't want it to run into the actual chuck. So I think that I'd be safe with being able to use about 440 millimeters of this, which means I'm going to have about this much left at the end inside my chuck. And then I can go ahead and zero somewhere around here, and I should be all right in the end. So let's go ahead with that for now. So the length of this is going to be 440. The diameter is going to be 60 millimeters. Again, we're using millimeters. And this is where I need to think about how I'm going to zero my Z position. Now, because I'll be using this router bit here, router bits, to find my X and my Y, I could also use this to find my Z, and that would give me a real accurate way to find the middle of my dowel. But for me, that causes a bit of a problem because I'm going to be changing some bits, and the way our setup is, it makes it a little bit more sort of cumbersome to work with. So I'm going to be zeroing off the material surface. Again, as I mentioned, this is not perfectly round, so I might end up getting a thick spot or a thin spot, but I'm not going to worry about it. Hopefully it'll all work out in the end. Okay, so that's that. So we're going to go ahead and zero off the top of our cylinder surface. My XY datum is going to be down here on this corner. Okay, so keep that in mind. You can decide to put that wherever you'd like it to be, whatever's easiest for you. Now the orientation, and like I had pointed out earlier, the orientation of our rotary attachment to our machine is along the X-axis. That's why I've chosen that. We're going to be wrapping the Y. And I've chosen to leave flip design on. That doesn't matter because I don't have a design to flip. So we're just going to leave it as it is, and it's going to draw, and it's going to cut what I draw, which is perfect. And then I've got my modeling resolution. Because I'm not cutting any 3D content, but it's important to remember that you can cut 3D content on your rotary with our software. I'm only going to be doing 2D stuff, so the modeling resolution doesn't matter. I'm just going to leave it at very high because my computer can handle that, but it's not going to change the cut quality at all for you. And the actual material is going to be Canadian maple, although this is actually tulip wood. I think I mentioned that, which is popular in other parts of the world, in case you're wondering. So we're just going to go ahead and click OK. So the first thing we're going to do is we're going to explore using some different toolpaths. So the toolpaths that we're going to start to use will be a profile toolpath with a V-bit. We're going to use a pocket toolpath with an end mill, a fluting toolpath with a ball nose end mill, and then some text with a V-bit, the same V-bit that we're going to use in our other tests around the end here, which you haven't seen yet. Okay, so let's just go ahead now and draw a line. So we're going to draw a line from the top of this down to the bottom, straight down. Okay, and that line's length is actually the circumference of my material. So if I cut this with a profile toolpath once around, then it would actually go from one end to the other and it would touch the other end. Of course, keep in mind that the geometry of your tool is going to come into account when they actually line up, whether it's going to be a smooth finish or not. So just keep that in mind. We're going to use a V-bit, so it should be perfect. That looks good. So now one of them would be nice, but I'm actually going to make 2 lines here and 2 lines down here, the other way around, I guess. And that way it'll look more like a pillar. I hate to waste a sample, so or a test, so this will hopefully make a nice little sample that I can use later on to show people. So I'm going to hold down my, let's flip over to our 3D view just for a minute. You'll see right away that I just have that one vector floating out in the middle of nowheres, which isn't very helpful. I can also go ahead and turn on my material block, which gives me this piece of round dowel. So that's just the size that I set up. And if I turn on my zero plane, you'll see that it lays it out flat. We don't wrap the modeling plane. Only time that's going to happen is when we actually 3D preview our tool paths. So let's leave it like this as it is. Let's hide our material block because we don't need that. And that's great. So let's grab that vector and we're going to go ahead and drag it across, holding down our Control and our Alt key, and we're going to make 2 lines like that. Then we're going to grab these 2 vectors that I have, and I'm going to hold down my Control, my Shift, and my H key. So the Control is going to make a copy, Shift is going to copy it across the plane, and H is my horizontal plane, and there we have it. So now I've got these nice 4 lines here that I can go ahead and tool. So let's grab those, jump over to our Toolpaths tab, and let's look at the Profile Toolpath. We're going to start at the top of our material. We're going to cut down about 3 millimeters. I think that should be good enough. We're going to use a V-bit, the normal 60-degree V-bit we always use. We're going to cut on the line, and all these other settings don't matter right now, and we're just going to go ahead and calculate that. Okay, if we preview that visible toolpath, you'll see that we just get 2 lines on that unwrapped surface. So now let's just go ahead and rewrap that and we'll see what we get in the end. And you'll see that that's exactly what we're going to see. 4 nice lines. Now what if I wanted to go ahead and create a diagonal line between these 2 lines and maybe make it look like it's going all around, maybe 2 or 3 or maybe even 4 times. Let me show you how to do that. So let's unwrap that. Look back down on the top of it again. We're going to close this down. Okay. I'm going to grab one of these vectors. And then we're going to copy it, Control C, Control V. So now we've got a copy of it there. And then we're going to go ahead and move, we're going to go to node mode, excuse me. We're going to grab this node and we're just going to snap it over here. So now we know if we cut this, we're going to go around once, okay? But it's going to look a little funny because it's only going to go from one side to the other and it's going to not look right. But we're going to make it 4 times as long. So to do that, what we can do is we can just go ahead and press T on our keyboard and make sure we have this unlinked, okay? And we're going to change this height to be 4 times that. So hold down our Shift key, press the asterisk, we're going to make it 4 equals, and then we hit apply, and there we have a line that's 4 times as long. Then what I can do is grab this bottom node and just snap it to that spot right there. That looks great. Let's close this down. And now we can go ahead and see what this is going to do for us. So let's grab that. Let's create another profile toolpath. Okay. Same settings as before. Cut on the line, and we'll calculate that. And if we preview that visible toolpath, look at that. And if we go ahead and wrap that, you'll see that we're going to get this kind of a corkscrew or threads of a screw kind of look at the top. That looks really great. So let's go, now that it's worked out okay, let's go ahead and do the same thing we did before. Hold down our Control, Shift, and H key. Let's grab that, go back into that toolpath again. Let's hold down our Shift key and grab this one. We'll recalculate that because we want that to be happening on both ends of this. And we can preview those toolpaths again. And there we have that same look on each side. That looks pretty good. Great. Top down. Let's close this down. Let's unwrap that. Now the next thing we're going to want to do, or that I want to do, is try the pocket toolpath out, okay? So let's go to our 2D view just for a moment. And we're going to create a pocket toolpath between these 2 vectors right here. So to do that, we're just going to create a rectangle. And we're going to draw a rectangle in there. It's going to snap to all the corners, close that down, and we'll grab that vector. Let's go back to our 3D view for a second. And let's do a pocket toolpath. So we're going to start at 0. Let's go down 3 millimeters, just like we did with those the profile toolpaths we did a second ago. We're going to use an end mill. That's perfectly fine. We're going to use a raster toolpath. Okay, and we're just going to go ahead and we're going to calculate that. And then we can preview that visible toolpath. And you'll see it cutting down through it. Let's wrap that around. Now what we're going to notice is at the end we've got this little fin that's sticking up. Again, that's because of the geometry of our tool. When it comes to the actual other side, it's leaving a bit of a cusp there. So in order to deal with that, the best way we can do it is to take that rectangle, press T on our keyboard, and we are going to make the height of it, we're going to add the diameter of our tool to that. So in my case, it's about 0.635. So if we go plus 0.635, sorry. Okay, and we go equals, then we can hit apply again. I have the link XY unlinked, so it's going to make it slightly longer. Close that down. Let's go ahead now and recalculate that toolpath. And let's preview that. We'll see that we should end up removing those little fingers at the end, and now we have a nice smooth pocket in there. That's exactly what we want. That's going to look pretty neat in the end. I like that. We get that kind of half a V-bit going on here, which is going to be neat. Okay, great. Let's go ahead and unwrap that for a minute. Let's close this down. The next thing you want to do is to add in some flutes. I think that a lot of people are going to want to try to use flutes on their different rotary jobs. They look really kind of nice and they add a nice little detail to things. So let's go back to our 2D view again. And what we're going to do is we're going to draw a line just anywhere here, across here. And we're going to snap from the top of that box to the bottom of that box, or from the left to the right. Press escape. With that selected, we're going to go ahead now and choose to array copy that. So we can go ahead and make maybe 10 of those. So we're going to go ahead and create 10 rows, 1 column, and we're going to go ahead and hit copy. That looks great. Close that down. Now I want to make sure that they fit between those lines perfectly. So with those selected, I'm going to select it again. I'm just going to drag it up. So that way now they're all evenly spaced around the circumference of my job. And I'm going to delete out this top one because I'm doing the bottom one. So there's no point in doing that twice. So delete that out of there. Now the next thing I want to think about is, have I taken into account the geometry of my tool? If I use a ball nose and mill for this, what's going to happen is that the ball nose is going to run in to the edge of that V cut or that profile cut with the V bit that I made, so the half V that's left. And I don't want it to do that. So what I'm going to do is I'm simply just going to go in and just size those in just a little bit, just to avoid that. So I hold down my shift key and drag that in like that. You'll see that holding my shift key shrunk it from both ways, and that should be all right. Let's close that down. That looks really good. So let's go ahead now and try the fluting toolpath. So let's grab the fluting toolpath, and we're going to have a start depth of 3 millimeters, because remember we pocketed that out, so we're going to make that 3 millimeters. And then we have the fluting depth. We can make it, we'll make it 5 millimeters. Let's make it 3 millimeters just to make everything nice and even. That looks really good. We'll use a ball nose for that. We're going to go ahead and ramp at the front, or the start, and at the end of our flute. So it's going to end up doing this kind of thing, like a scoop. We're going to make it nice and smooth, and we can go ahead and calculate that. Great. And now let's just go ahead and preview that visible toolpath. And then if we go ahead and put that back in the rotary view again, we're going to see we have that. You know what? I think I want to go a slight bit deeper. But before we adjust that, I want to make one other little change. I want to remove one of those flutes out of there and put some text in there. So before I recalculate this fluting toolpath, I may as well go ahead and edit the actual vectors that I want. Unwrap that. We can turn on our vectors if we'd like to in the 3D view. I'm going to take out this center one. Let's just go to our 2D toolpath for a second. There we are, our 2D view, sorry. And we're going to delete this out of there. There we are. Delete you out of there. That's perfect. That'll be all right. And then we're going to double click on our fluting toolpath. And let's go a little bit deeper. Let's make that 5 millimeters. Make it a little bit more dramatic. Let's preview, let's reset or undo the last one. We'll preview this new toolpath. I'm way happier with that. That looks much better, I think. Yeah, way better. Cool. Okay, great. Back to our 2D view again, and let's type in some text in here. We're going to use a nice sort of blocky font. I like Candera. I use it quite often for a lot of things. So let's just go ahead and type in Rotary in there. That's great. And we'll close that down. Let's drag that into our view here. Hold down our shift key. Make that a bit bigger. That looks pretty good. Let's grab that. Close down that. Jump back to our 3D view for a second. Unwrap that. There we go. So now what we can do is go ahead and V-bit that. So we're going to use some V-carving on this. V-bit that. Anyway, so we grab that. We're going to use a start depth again of 3 millimeters. We may as well go down whatever it actually works out to be using the geometry of our tool and the V and the vectors that we have there for that text. We'll use our 60-degree V-bit. That looks great. Let's just go ahead and calculate that. And let's preview that visible toolpath, and let's wrap that. And this is what we're going to end up with in the end, once all those toolpaths are run. So you can see how easy it is to apply two-dimensional toolpaths to your rotary job, or 2.5D toolpaths. So what we're going to do now is we're actually going to go ahead and save off those toolpaths, and then we'll go over to the machine and get it all warmed up, and then we can talk about how we're going to get this put into our the chuck, and also get it all lined up nice and flat. Okay, let's do that. Okay, so there we go. We got those toolpaths saved off for a bit later. Okay, so a couple things to keep in mind. One is that I wanted that spiral to go around 4 times, and when I went to save off the toolpath, that dimension ended up exceeding the maximum dimension of a toolpath we can have a Vcarve Desktop. So I modified the file. It's only going to go around 3 times instead. Now also make sure that when you save off your toolpaths, you use your Rotary toolpath post-processor for your machine, okay? That's really important. If you haven't installed that yet, you can do that through the machine management of your software. Okay, now we've got the toolpaths, we've got our material. Now what we need to do is we need to find the center of this, and that's going to be important. So when I go ahead and mount this material in my rotary device here, I can put the tailstock right in the center, and that'll help me to ensure that this thing is nice and flat. I'll also use a level just to kind of make sure that everything's okay. And that's where this center finder comes in. Now, if you haven't seen the center finder yet, then we're actually going to include this in the finished files for this project, but also there's a nice little quick little tutorial on YouTube, or sorry, on Instagram, that'll help you figure out how I made this thing. So go ahead and check that out. And this is going to be super handy for this kind of work. So what we're going to do is we're just going to place on the end of this stock like this. I'll use my pencil here, and I'm going to draw a series of lines. So I'm going to draw one line, then I'm going to rotate it, grab it again, and draw another line. I'm going to do that just a few times here, trying to hold this in a funny way. Let's just do this. That's a bit easier. There we are. Now I can just go across like that. And as I do that, what you're going to see happen is even if I'm not perfectly centered, my material isn't perfectly round, I'm going to end up having a little shape in the middle that I can use for the center of my job. So let's just go ahead and take a look at that. Let's just go do it a few more times just so we can be sure everything is all right. That's pretty good. And you can see it's starting to draw a little bit of a shape in the middle. So right about there will be the center. Now for me to do this easier because of the way this is orientated, I'm going to use a little screw. If you happen to have an awl, that would be great. And you can just go ahead and push that in the middle, and that'll start the hole. So when I mount this on my machine, then I can get it pretty much in the center. Okay, so I'm just going to push that in just a little bit. So now I have a little hole to start out with. So that's great. The next thing I want to do now, I get the machine warmed up, and then we are going to mount this bit, this rotary bit, in the inside of the chuck. And that way I can find my X and my Y location, move it out of the way so I can mount this into the jaws of the chuck and mount the tailstock, and then we should be able to get cutting this. So we'll see you in a second. Obviously, there's some chipping in there and so on that you probably saw in the video. I probably could have ran the Fluting toolpath one more time to clean those out. It's my first time ever using tulip wood, so maybe it's supposed to be stringy like that. Maybe my V-bit was a bit dull, but all that aside, this is a great test part because I learned all kinds of stuff about how this is going to cut next time around. You could go into that file and you could change it around a bit. You could change the orientation or the angle that the pocket cuts make. That way you might be able to get a different finish, might run a little faster. But I think overall, that's pretty nice. So now what I'm going to do is I'm going to take what I learned from that, and we're going to hop into the software and we're going to create a more practical project, maybe a candlestick. So let's go ahead and create a brand new file. Now we're going to use the same settings as before, except for we'll be using this piece of oak opposed to the tulip wood that we used last time around. So, and this is pretty much the right dimension. I've already measured it, and it's pretty much spot on what we need. So I'm hoping for a really good result from this one. So it's going to be a rotary job. The length is going to be 440 by 60, which again will give us space at the end for the chuck to grab a hold of it. We're going to make sure that we zero off the surface of our cylinder, bottom left-hand corner for our datum. We're going to be setting up the orientation just like we did before. Remember, make sure that this is set up appropriately for your machine, but we actually have our rotary along the x-axis, and we're going to, I still have the flip direction turned on, but you don't need to worry about that because there's no design at the moment. Again, we're going to use a very high resolution, and we're going to just use that Canadian maple as our material. So we're going to click OK. Now what I'm going to do is I'm going to zoom out a little bit, and I'm going to give myself a little bit of more information to work from. Now, what I decided to do with this job was I wanted to experiment with the molding toolpath on the rotary, which I thought would be a really nice way for people who don't have a spire to create some unique and customized 3D or 3D toolpaths for their rotary jobs. So the first thing I'm going to need to do is to create bring in a guideline actually first of all, and we're going to snap that to the middle of my job. And then we're going to draw a circle, a quick little circle that's going to be 60 millimeters. You see I've got the diameter set here to 60 millimeters. And I'm just going to click around here and we can hit close. So this is the circumference of my dowel. And this distance here is also the circumference of my dowel. So like we mentioned before, that's an important concept to understand. And then what we're going to want to do is with the molding toolpath, we need a drive rail and a cross section. I just moved that over a little bit so we could visualize this a bit better. And we're going to draw a cross section that's going to start at the top of our material and cut away some of it and come back up to the top of my material. I thought that was a nice, easy way to test this out. So to do that, I'm going to draw a vector, and we're just going to snap it there, and we're going to pull it out here. So we're going to go ahead and click here, go down to somewhere around here. I'm just winging this for now, but this will give us a good idea of what's going to happen in the end. And we'll go up to there, and we'll press escape. Go into node mode, which is N on our keyboard, and we're going to go ahead and grab all of those nodes and press B on our keyboard to turn those to a Bezier. And then I can go ahead and shape this. So this is going to come down the outside of my dowel, like you see here, outside of my dowel, down. Let's go ahead and turn this into an arc. So we're going to right click on this and turn it into an arc, and I can drag this up to make a full circle. Somewhere around there maybe. And then we're going to take this shape here, and we're going to make sort of a tulip shape about it, like that, like a tulip bowl shape. Big bulging belly there. And that looks pretty good. I just want to make sure that all of those nodes are nice and flat across the top, and they seem to be, so that's great. And then we're going to need a vector here in our actual dowel, so we can use the two rails, or use the molding toolpath, excuse me. So we can pull that down and click it there, and there we have it. So we have all the components now we need for a molding toolpath. Now keep in mind that this cross section is going to start at the top of my material and work its way down to the maximum depth of this vector, which is going to leave me quite a substantial thickness in the middle of my dowel, like a round core to it, which I think will be quite nice. Now, if you're not familiar with how the molding toolpath works, I highly suggest that you go ahead and watch how to use the molding toolpath video. We'll link it below. That'll give you lots of ins and outs of how this works, what you should include, what you shouldn't include. It won't include what we're about to see here, so this is kind of a nice little addition to that video. So that'll give you kind of the core basics, and then we're going to build on that just a little bit with this. So let's jump over to our Toolpaths tab, and we're going to go down to our molding toolpath, and we'll click that. So we're going to see here that we need to select a drive rail and a cross section. So holding down my shift key, we're going to go ahead and grab this cross section. And the first thing we're going to notice is that the cross section is hanging off the wrong side of the vector. It's going to the right, it needs to go, sorry, it's going to the left, it needs to go to the right. So what we're going to do is we're going to flip that over. So if I right click on my drive rail, I can say reverse direction, and it's going to put that cross section on the other side of that drive rail. Now the way a molding toolpath works is it's going to take that profile, and it's going to run my bit along that profile back and forth, and we're going to end up having a very nice smooth looking shape in the end without any 3D content. Again, if you want more information about that and how that works, you can refer to the other video. So we're going to make sure that we use a ball nose end mill for our finishing pass, which is going to give us a nice smooth finish. We're going to vary our step over. So as the tool goes down any steep walls or any round shapes, it'll end up compressing or making those step overs farther apart, so we'll get a nice smooth finish. We're going to use a large area clearance tool. So before we run that finishing bit, we're going to use a big end mill to hog out a lot of the extra material that we don't want our finishing bit to deal with. We are not going to use any, or we're going to use a little bit of machining allowance. That's going to leave a little bit of material behind, just like when you do a roughing pass when you're doing a 3D cut. We're going to leave some stuff behind for the finishing bit to go remove. We're not going to worry about create sharp corners. We're going to have zero boundary offset, and we don't want the software to calculate one for us. We want the molding toolpath to start at the start of the vector and at the end of my cross-section vector, not go any farther, okay? Especially in this particular design. You might need that later on, but for this design we don't. And we're going to go ahead and calculate that. Now when we do calculate that, you're going to see that in our toolpaths list, we have two different toolpaths. We have the clearance tool and we have the finishing tool. So if I hide the finishing tool, you'll see that that's the clearance passes that are going to be made. And if I go ahead and hide that and turn on the finishing toolpath, you'll see that's what we're going to get in the end. So let's go ahead now and preview both of those. We're going to preview those flat. A little easier to see what's happening. So let's preview those visible toolpaths. So there's the roughing pass going through and then the finishing pass. Then once we wrap that around, you'll end up seeing that we have a nice looking candlestick. Now feel free to go ahead and modify that cross section as much as you would like to change the shape of that to get exactly what you want. But I'm pretty happy with this. So now that we have the foundations of how to use the molding toolpath on a rotary job, instead of me going through the actual finished part that we're about to cut from start to finish, I'm going to go ahead and just load in that file so we can have a look at that as we look at that in its full thing right now. So here it is right here. And as you can see at the top of this, we have the design of the candlestick. We have a short version and a tall version. We have the top here, which is going to be I guess the top of the candle holder, which is going to hold our candle. And then we have the base at the bottom. Now these share the same top and base, so we only need one file to create those. We just need to cut it twice. And then we have the candlestick in the middle. If we take a look up under my sheets, pardon me, we only have one sheet. And if we look underneath our layers menu, we have lots of different layers here. So we're going to hide some of these. I'm going to hide my design, the bounding box, which we had talked about before, that gets created automatically for me. We're going to leave the molding toolpath. We're going to hide the top base, and we're going to hide the cut lines for right now. So as you saw a minute ago, we've got two profile lines, and we have two cross sections, a short one and a long one. Now the long one, just because I thought it would be nice if we had an option, and also I thought that instead of me stretching it up to be taller, I actually only stretched the top bit, this tulip bit, so that we could end up it just looks nicer because that ball at the bottom stays the same size, so they match still quite nicely. So let's hop over to our toolpaths tab for a second. Now we got some extra toolpaths we're not going to worry about right this second, but the first ones we want to look at are going to be the short candlestick. We've got the roughing toolpath or the clearance toolpath, and then we have the finishing toolpath. Look at the 3D view, and if we go ahead and lay that out flat, we can see that there. Okay, let's just go ahead and preview those really quick. There you go, there's the clearance tool, and then we have the finishing tool in there, and if we wrap it, we'll see what we have there. Now, like I had said, I'd put two, because I've got so much room on this dowel, I thought I may as well just stick two of them on there. So we got the second one right here, so let's go ahead and preview those visible toolpaths. Again, it's going to preview them flat, and then it's going to go ahead and wrap those around. There we have the two candlesticks, and I think they're going to look quite nice. The finish should look pretty much like you see there, nice and smooth with very little sanding to do. Now the last thing I wanted to do in this particular cut is to actually create some cut lines, so actually cut through the material and just leave a small kind of central dowel through the whole thing, so it made it easier for me to remove these from there. But also I needed to make sure I left a little bit of a lip at the bottom, that way it could fit into my base without ruining my design. So if we go ahead back over to our 2D view for a second, and also our design tab, and we turn back on our cut lines here, you'll see we have these orange lines here. Now those are going to be my cut lines, and those are just simple profile cuts going down to a depth. Remember, we are going to go ahead and cut down not the 60 millimeters, but down to the center, so that's 30. So if I cut down 20 millimeters, it's going to leave 10 millimeters on each side, so that's going to leave me a core of about 20 millimeters in the center. So you need to do that little bit of maths in your head. But it's pretty easy to do. Let's flip back over to our Toolpaths tab. Now I'm going to show you a really good top tip here about how to use the profile toolpath on an open vector. So if we go into this, this first cut line, you'll see that I'm chosen these two lines here to be my cut lines. These are going to cut almost all the way through my material. It's just a simple profile cut. It's going to go down, so 30 minus 10, so it's going to be 20 millimeters. We're going to use that end mill that we have. Okay, we need to make sure that we cut on the right side of the line. So the way to kind of visualize what side of the line you want to cut on is pretend you're in a car and position yourself at the start of your vector and you're driving towards the end point. And depending on what side of the line you want to cut on, so in this case, I want to cut on the, I believe it's the right-hand side, left-hand side. I want to make sure that that's on the right side of the line, left side of the line, yeah. Just make sure you're driving down the line and you're cutting on the side of the line that you want to. And it's really important that you preview your toolpath to make sure you get what you expect. So if I calculate that, we're going to be given a warning. It says right away that we have some open vectors and that it just wants us to be sure that that's what we want to cut. And that's exactly what I want to cut. So we'll just go okay. Let's preview that visible toolpath. And you'll see that now we've actually cut on the wrong side of the line. Okay, you can see that because I wanted to leave a little bit of a piece here at the bottom. So let's undo that. Let's go back into that toolpath. Let's quickly go ahead and flip to the other side of the line. And we can calculate that. And we'll preview that. And now we're going to be on the right side of the line. And there we have that little bit of a lip. Now, if that's a bit confusing for you, the best way to visualize this is to go to your 2D view, turn on your solid toolpath previews, make sure you have that toolpath turned on, and you'll see what side of that line you're going to be cutting on. And I'm going to need to just reverse this one as well to the inside. We'll calculate that. We'll click OK, and we'll preview that visible toolpath. But first of all, let's take a look at it in our 2D view, and you'll see that now I'm on the other side of the line. It's exactly what I want. Let's preview that visible toolpath. Go back to our 3D view. And that's what we're going to have in the end. So that's going to allow me to get in there and cut those apart. You'll notice that I have double the space in the center here. I did that mainly because if I just wanted to cut one candlestick at a time, I didn't need to worry about things. But anyway, that's just the way you can thin that out if you'd like to. Last thing I'm going to do before I save off these toolpaths and run them on the machine is I'm going to organize them just a little bit so I don't have to do too many tool changes. So I'm going to take the sweep for the tall candlestick and move it underneath the short sweep, the clearance toolpath. Those are both clearance toolpaths. So they're going to use that end mill. So when I save these off, I can group those together and save them off as one toolpath. Now what we're going to do is we're going to go ahead and save those off. We're going to go over to the machine, set it up, get ready to run these. We'll run them. We'll take them off. We'll take a look at the finished thing. And then we'll take a really, really quick look at how I made the base. And then we'll go ahead and cut those. Okay, let's get to that. Really good. There's a bit of chipping around the top and the bottom of the actual candlestick, but that's okay because that's going to be hidden inside of the base. Now, talking about the base and the top of the candlestick, there are lots of different ways you can do this. So I had my own way of doing it, and what I'm going to do is I'm going to show you the file that I created to make my top and base for the candlesticks, and it uses the same molding toolpath that we used to make the actual candlesticks with. So let me go ahead and open up that file and then we can dig right into that. Okay, so I'm going to go to open an existing file, and this file will be installed right into your file folder that comes with your free project. This is going to be the candle holders top and base. So Farmhouse candle holders top and base, and we'll open that up. And we brought right into the 2D view once this pops up here. And you'll see that what I've done, oh, there's the error. Now, not the error, but the warning. You guys know all about this warning. Make sure that you review this file in full before you cut it on your own machine, okay, taking into account the feeds and speeds, the material you're going to be using, and the tools you have on hand, okay? Just click OK. Now, we're in the 2D view right now. Let's flip over to the 3D view, and we'll have a look at that. So now, first of all, I've already cut a sample set of these already, just to make sure everything was going to work out and was going to fit together okay. But with that material that I used for the samples or the test parts is a slightly different thickness. So what I'm going to do is I'm going to do exactly what you should do, is to grab the material that I'm going to use to cut these into, make a quick measurement here, and make sure that I adjust my tooling appropriately. So let's just go ahead and do that. And it's about 23.3-ish where I'm going to set my zero from. So let's just go ahead and pop over to our Toolpaths tab, up into our material setup, and change the material thickness to be 23.3. Then I can just go ahead and click OK. I'll be given a warning in a second here to say that I should probably recalculate all my tool paths. Let's go ahead and do that right quickly, and then we can review those, okay? Now this is going to be a two-sided project because I've decided to pocket some out in the back of this. So let's first of all take a look at the top side of this. We can go ahead and review the molding toolpath. So like I had said, I'm going to use the molding toolpath like we did for the actual candlestick. There's the cross section, and this is the vector that I'm going to use to hang that off of for the base, I guess. And then this is the cross section and the vector here that I'm going to use to create the top of this. Just a quick top tip for you if you hide my toolpaths here, that let me just look down on this, that I'm actually hanging it off the inside vector. So I created this outside vector first, offsetted it in the width of this vector that I'm using as my profile, and I'm actually going to use this inside vector for my molding toolpath. That way it'll line up perfectly with what I hope the outside dimension is going to be. So let's just go ahead and take a look at the first one here. We'll just recalculate that, although we don't need to, it's already calculated. We can preview that visible toolpath, and you'll see that we're going to get a nice top to our base, and we can go ahead and take a look at the top. We'll just preview that visible toolpath, and then we'll preview the sweep for that as well. Again, molding toolpath, you get two toolpaths with that. That looks great. Now I've also decided to design into my base and lid some important, not lid, base and top, some important features. One is that you'll notice that my top has been flipped upside down, but there's a recess in the bottom of the top that will accept the top of the candlestick, but also there's this other little hole right here. And that's because I wasn't sure whether or not I was going to be able to cut that center piece off perfectly straight. And I didn't want to do a whole lot of sanding because I want these to sit pretty flat. So that will give me a little bit of room to leave a little bit of that center dowel behind, so that, and it gives it a place for it to kind of tuck away so everything lines up nice and flat. So that's what these next two tool paths are for. So there's the stick pocket, the extra stuff, the dowel holes for our two-sided flip. And if you've never done a two-sided flip before, we've got lots of videos to help you with that. I'm using the asymmetrical dowel pattern, which makes it really easy to do. And then we have a profile cut. So let's just go ahead and preview all of those tool paths and see what we end up with. You'll notice that my profile toolpath doesn't cut all the way through. That's because on the back side is where I'm going to be doing all of my cutting for that. So I just flip the part over. You'll see that now I can go ahead and preview all those tool paths, and you'll see what I'm going to have in the end. I've got a nice pocket in the middle to put my candle in. This hole in the bottom of the base is so that I can add in a screw later if I want to. I thought this would help me line it up a little bit better once I have it all glued together. And you'll see that I've added the tabs on this side to actually go ahead and cut it out. So I think I know that's all ready to go because, like I said, I've already cut a sample already. So what I'm going to do is I'm going to go mount a sacrificial wasteboard on the CNC machine, mount my actual material I'm going to use to cut these out with, and go through cutting those out. And then once we're all done with this material, I'm going to pull off the dowel for the middle bits, and we'll cut those all up. I'll put a nice finish on them all, glue them together, and then we'll come back and we'll talk about all that in the end. Okay? I'm excited about this. I'm really happy with the way these turned out. Off camera, I added a few clear coats, a little bit of sanding in between, and I think they turned out really nice in the end. I don't think I'd change too much about these. So in this video, you would have seen me make this center finder to help us center our dowels on our CNC machine on the rotary attachment that you have. I showed you how to make this sample part that will show you whether or not our software is compatible with your rotary attachment, and make sure you're happy with that. And then also how to create these candle holders. Now let's not forget that this project is totally trial friendly, so even if you don't own our software, you can go ahead and download the trial version and try these out on your own. Well, I hope you liked that as much as I did. If you liked this video, please give it a thumbs up. If you haven't subscribed to our channel, please do. If you have any comments or questions, please leave them below and I'll get back to you as soon as I can. And for now, keep making fun stuff, and I hope you take some time to make these.